Hello and welcome to Mechanical Why. Let's assume that this is the length of 1 light year. In this scale, how large would the solar system be? At Neptune's orbit, our solar system would be roughly the thickness of this piece of paper. Now let's look at how far the nearest star is to our solar system. Proxima Centauri is 4¼ light years away, so 4¼ times this length, or approximately this distance. So how far have we made it to cover this type of distance? Well, Voyager 1 was launched in 1977, and in roughly 40 years it has traveled 137 astronomical units, or 137 times the distance between the Earth and the Sun. In this scale, that would mean that would encircle a sphere roughly the thickness of 5 of these sheets of paper. That is the furthest we have ever traveled. Even after 40 years of flight, and Proxima Centauri is our closest neighbor. But the universe gets bigger. How big would our galaxy, the Milky Way, be in this scale? Though we don't know its precise size, scientists estimate that our Milky Way is about 180,000 light years in diameter, in the scale that is roughly the size of the I-285 perimeter around Atlanta, Georgia. Every star we see in our night sky is contained in that Milky Way. Stars beyond our own galaxy are just too far to see unaided. But let's think about our nearest galactic neighbor, the Andromeda Galaxy. That is some 2.5 million light years away. If our Milky Way is the size of Atlanta, Georgia, then the Andromeda would be all the way down in Savannah, Georgia. Some 470 kilometers or 230 miles away from this piece of paper. The furthest distance object that we have detected from Earth is about 13.4 billion light years away, meaning that if this is 1 light year, that object is about 5 times the distance to our moon. But here's the interesting part. If this is 1 light year, then how fast would light be traveling? What can we relate to that would look like light speed in this scale? The answer is the speed my hair is growing. That is what the speed of light in the scale looks like. To get from here to the Andromeda Galaxy would be as if I sat at the Washington Monument in Washington, D.C. and waited for my hair to reach the Connecticut border, and that would be the fastest we can travel. According to Albert Einstein, light speed is the fastest possible speed in the universe. Light usually feels like it travels so fast, but looking at it in this way and at this scale and thinking about what it would be like to travel to our nearest galaxy, the speed of light seems awfully slow. And there are millions of galaxies that are much further out. Intergalactic travel cannot be done in our individual human lifetimes, not even in the lifetime of our entire species, but on the order of the life of the Earth itself. And that's just to get to our nearest galactic neighbors at light speed. While it's always possible that we find some special side of physics that allows us to travel faster than light, for the foreseeable future we're going to be staying quite close to home. Thank you for watching. I hope you found this interesting. If you did, please like and share this video, and don't forget to subscribe to stay up to date on new content.